This video, we're going to start out with some basic trig identities. These are given in the chart at the top of your screen. If you want to pause the video to jot these down, you can. You can also find these in Google Drive, where I save the daily class documents, or in the identity sheet. The identity sheet has several different categories. These are the main three we're going to focus on today. Okay, so if you paused, welcome back. If you didn't, we're just continuing. Uh, we're going to start out with some simplifications of trig expressions using some of these identities. If you notice, one of these identities is already marked up. 1 plus cotangent squared theta equals cosecant squared theta. If you were to subtract 1 on both sides, that would give you cotangent squared theta equals cosecant squared theta minus 1. If you correctly manipulate an identity with an algebraic operation, it's still an identity. All right, so we're going to use a reciprocal identity to simplify secant theta cosine theta. One way to do it is to change secant theta to 1 over cosine theta, and then you get a cancellation equals 1. Or you could change cosine theta to 1 over secant theta, and then your secant thetas cancel, giving you 1. Either way gives you the correct simplification. It's just a matter of which one of these trig functions you want to swap out for its reciprocal. A secondary example would be sine theta times cosecant theta. You can swap either one of these for its reciprocal. In this one, I just chose to change cosecant theta to 1 over sine theta. Your signs cancel and you get 1. In any case, if you have a trig function times its reciprocal, your answer will be 1 every time. Use a Pythagorean identity to simplify cotangent squared theta minus cosecant squared theta. In your Pythagorean identities, if you jotted those down or if you have them handy, cosecant squared theta can be replaced with 1 plus cotangent squared theta. That's an identity you can do a direct swap. Subtracting both terms changes both of their signs. Your cotangent squared thetas will cancel. They add up to 0, leaving you with a negative 1. Use a Pythagorean identity to simplify cosine theta times 1 plus tangent squared theta. In this one in class, you guys told me that it was appropriate to trade out 1 plus tangent squared theta for a secant squared theta. And because that's an identity, you can swap those out. Cosine, by its reciprocal, is 1 over secant. Cancel a secant theta from top and bottom, and that will leave 1 of your secant thetas. And that's as simple as this one will go. Oh, also note over here to the side, this is where I jot down the identities that you give me in class. And so you guys have done a really good job. It just takes some practice and hard work. Use a quotient identity to simplify cotangent theta times secant theta. From the quotient identities, you guys told me that cotangent theta was equal to cosine over sine, and that's accurate. So we can trade out cotangent theta for cosine theta over sine theta. Secant theta by its reciprocal is 1 over cosine, and that will lead to a cancellation. If we cancel a cosine theta from top and bottom, that reduces down to 1 over sine theta, and its reciprocal is cosecant theta. So that gave us quite a bit of a reduction. Use appropriate identities to simplify. Now, on this one, I'm making the directions a little more vague so that you have to think about which identity is more appropriate to use. And just kind of keep in the back of your mind, The goal of these is to try to get down to as few terms as possible, ideally one term or one numerical value. Secant squared theta minus 1. This one, if you remember from the first slide, where one of the Pythagorean identities was highlighted and there was an arrow leading away, this is a case of where you can take an existing identity and by correctly modifying it with an algebraic move, specifically subtracting 1 on both sides, you can create another identity. Tan squared theta is equal to secant squared theta minus 1. So that numerator, you can actually trade it out for a tan squared theta. Over to the side, I just want to separate these. Tan squared theta times 1 over sine squared theta. And that's all I did here, was I just separated the fraction. From quotient identities, tan squared theta is sine squared over cosine squared theta. Times your 1 over sine squared theta, that gives you a cancellation. You can cancel sine squared theta from top and bottom, and that'll leave 1 over cosine squared theta, which is secant squared theta. And for our third example, use appropriate identities to simplify tangent theta, cotangent theta over secant theta. Remember, these are reciprocals, and reciprocals have a product of 1. 1 over secant theta is cosine theta, and that's from the reciprocal identities as well. But just make a note, if you ever spot the product of reciprocals, your answer is always going to be 1. And that's even true with numerical values like 5 times 1/5 or 7 times 1/7. You're always going to get a product of 1. At the very bottom, use appropriate identities to simplify tangent squared theta minus tangent squared theta sine squared theta. This one was kind of a handful to look at first. In class, we looked at alternate routes, and they all seemed to be pretty hectic as far as the number of steps it took. We eventually got it. One of the more streamlined processes for this one would be to factor out a tangent squared theta from both terms. That's 1 times tangent squared theta minus sine squared theta times tangent theta. If you factor out a tangent squared theta, that's going to leave a 1 minus sine squared theta. If you were to redistribute, you get the original problem. So you know it's factored correctly. If you modify the Pythagorean identity, sine squared theta plus cosine squared theta equals 1, if you subtract a sine squared theta from both sides, then you have cosine squared theta is equal to 1 minus sine squared theta. Therefore, you can do a direct trade. Tangent squared theta from its reciprocal or quotient identities, not reciprocal, quotient identities, that is equal to sine squared theta over cosine squared theta times this cosine squared theta will lead to a nice cancellation, leaving you with sine squared theta. I hope this video helps. With identities, you have to think about reducing with appropriate algebra methods and also using your identities for direct trades. You want to try to trade out your terms and or reduce them to smaller, simpler terms. I hope this video helps. Reach out by phone or email as needed. If you're on campus, stop by the office.